Climate stabilization wedge. The climate stabilization wedges is an approach produced by Princeton University researchers Pacala and Robert H. Socolow, looking at climate change mitigation scenarios. The project was funded by Ford Motor Company between 2000 and 2009 and has been receiving funding from BP since 2000. The goal of the approach is to demonstrate that global warming is a problem which can be attacked using today's commercially available technologies. The objective is to stabilize CO2 concentrations under 500 ppm for the next 50 years using wedges from a variety of different strategies which fit into the stabilization triangle. A newer estimate by the original authors indicated that by 2011, the number of necessary wedges had increased from 7 to 9. This was due to the continuing increase in emissions since the original 2004 paper, which determined the number of wedges that would have been necessary if serious action to mitigate climate change had begun then. Concept. Scenario. Emissions of CO2 and other greenhouse gases have been increasing ever since the Industrial Revolution. If the trend continues to hold, emissions will double by 2055. To prevent the worst consequences of global warming, scientists recommend freezing and reducing net global emissions immediately. Stabilization triangle. If global emissions of CO2 are graphed for the next 50 years, the difference between the business as usual scenario and the flat path forms a triangle. This triangle is known as the stabilization triangle. Pacala and Socolow divided this hypothetical triangle into 7 stabilization wedges, which represent different measures that must be taken to reduce emissions. When speaking of different strategies to reduce emissions, the language "to reduce one wedge's worth" is often employed, and by reducing the stabilization wedge of 14 gigatons of CO2 into 7 wedges, the task is much easier to conceptualize. Wedge strategies. As Pacala and Socolow originally presented the wedges concept in Science, there are 15 different wedge strategies. Regarding the specific number, Socolow says that he and Pacala didn't include all of the possibilities, but that it was a matter of rhetoric to stop at 15 and exhaustion. There was nothing magic about 15. On the CMI website, the same strategies are presented and expanded upon in detail, and are reorganized into 9 categories as of 2020. Efficiency, fuel switching, carbon capture and storage, forest and agricultural soils, nuclear, wind, solar, biomass fuels, natural sinks. Uses. Education. The Carbon Mitigation Initiative (CMI) permits anyone to use the game and make use of their materials, provided that they share the results with CMI. Because it is so widely accessible, it has become included in certain high school curricula. The Keystone Center has deemed the stabilization wedge game to fulfill the following national education standards: SON, S6, L4, L5, C4, C5, EON, GON, G5, and WH9. The American Association for the Advancement of Science hosted a conference for educators at the Hilton in San Francisco 2007-2-18. Collaborating with us were the National Science Teachers Association and the United Educators of San Francisco, representing the National Education Association, and the American Federation of Teachers. Dr. Socolow and Dr. Hotinsky personally presented the stabilization wedge concept at the event. Business. The stabilization wedge game is also used as a centerpiece for business seminars. Business executives played the game at a seminar held by the Sustainable Enterprise Academy at York University in Toronto. Criticism. The primary critique of the wedge game is that it is too simple, especially regarding the economic aspect of global warming mitigation. The materials provided by CMI only attach $1, $2, or $3 signs to each wedge as a broad estimate of the expense of each option. James L. Connaughton, former chairman of the White House Council on Environmental Quality in the Bush administration, is a critic of the wedge game for its oversimplicity, and he has even said that some of the numbers used by Socolow and Pacala, such as 550 ppm as a maximum allowable target for sea ottwal, lack a scientific basis. Richard G. Richels, a senior engineer at the Electric Power Research Institute, says that the lack of economic precision in the game could create misconceptions. We have to find out what it's going to cost to make it affordable. By not including the cost issue, people come away from this thinking it will be a piece of cake. It's going to require some serious bucks. If the environment is priceless, we should be willing to pay some serious bucks to protect it. Another criticism of the game is that one of the premises, i.e., that humanity already has the tools and technologies to halt climate change, is misleading. Marty Hoffert of the New York University Physics Department claims that while the technologies are available in a technical sense, they are not available in an operational sense, and it will take a massive mobilization to make progress. Hoffert explains, humanity had the know-how to build nuclear weapons in the late 30s or go to the moon in the 60s. But it took the Manhattan and Apollo programs to make it so. An Apollo-like program in alternate energy is needed over a broad spectrum of mitigation technologies. In a 2010 Science article, Hoffert also suggested that 18-25 wedges may be necessary to achieve the goal, given the higher rates of emission growth that have occurred since the original study, even if no new sources were added beginning in 2010. In June 2008, Joseph Romm argued in Nature magazine that if we are to have confidence in our ability to stabilize carbon dioxide levels below 450 ppm, emissions must average less than 5 GTC per year over the century. This means accelerating the deployment of the wedges so they begin to take effect in 2015. The 2007 IP reports state clearly that economic and demographic growth are the fundamental drivers of global climate change. Yet, of the 15 wedges developed by Pacala and Socolow, only one, having the number of miles driven by the world's automobile fleet, might be considered a demand reduction wedge. None of their wedges treat population reduction. References